Hi, Praveen. Right. Lim Avril, good evening. Ng Jia Swan, good evening. Yeah. Nurina, good evening. Ilyas, right. Good evening, everyone. Yeah. Thank you, those of you who responded over the chat. Right. So, anyway, I hope that yesterday's session was enlightening. You managed to learn a few things. And how many of you have actually accessed the system and tried out the practice session? All right. How many of you have done it? Can I see practice in the chat room? All right. Practice in the chat room. Practice, yes. Okay. Aiman said it's quite challenging, right? It's quite challenging, yeah. So I hope all of you managed to have a go at it, right? Because the approach that we are taking is the logic behind the solutions, yeah. Learning the syntax and learning the language itself is one thing, but how do we approach it in a logical way? The whole point of the competition is to test your logic, your programmatic ability, your problem solving ability, the ability for you to look at a particular scenario and can you able to identify the problem statement and solve it programmatically, right? So that's the angle we're going for. Of course, as we go on into day 2, 3, and 4, the level of difficulties and the questions will get a little bit more challenging. And towards the end, we will give you access to questions which are more similar to the ones that you will have in the national, the university level and the national level competition, right? So that will give you a little bit of familiarity and practice. So before we start today's session, right? So I want to like run through with you a few right areas of the competition. So just to give you a context on why this competition is important and why all of you would need to be a part of it, right? Because all of you who are part of the workshop, okay, some of y'all may not participate because you may not have the confidence or you may not have what you call want to take part in the competition, which is fine, right? But we highly encourage everybody to take part in the competition just to give an exposure. At least you know how's the experience of competing, right? Whether we win or whether we become a top ranker or not, that is besides the point. The spirit of participation is important. And through this competition, we are hoping that we build on fundamental skill set, right? Because the programming language or the scripting or the technology, it will evolve. It will change, right? Today is the Python, tomorrow there's something else, you know. So when I did my degree in IT 20 years back, we learned COBOL, right? COBOL, and then Java came into the picture. Back then there was C, C++, and then the .NET, you know. So the languages keeps changing, and now it's Python, right? So, but doesn't matter what is the language, what is the script, but if you have the fundamental skill set, such as problem solving, such as adaptability, you know, how do you adapt to new problem domain and concepts, right? Because the number one skill in the industry is agility, right? Learning agility, adaptability. These are things which are very much in demand. So you need to adapt, right? Debugging. Debugging. We all take debugging for granted. Like during my days, it was all command line interface, right? And when we learned, uh, the error message doesn't say much, right? We have a syntax error or a comma missing somewhere, you know, a parenthesis missing somewhere. We have to like go through manually. But today you have like error messages, which is a very detailed. It shows you where the error, it shows you what the error is, and how to fix it even, right? But a lot of our talents from the university have trouble into, even with all the assistance and trying to identify and do debugging, so which is a basic skills. So through the competition we are hoping that we are expecting you guys to like have more practice into this specific skill set, right? Programming proficiency, algorithmic thinking, right? And continuous learning. So these are skill and competencies that we hope to cultivate through this program. And of course, this competition is open to all students, regardless of whether you are from IT faculty or not. Even if you have not seen a line of code in your life, we encourage you to participate, because this is one opportunity for you to get the awareness and have some form of hands-on experience, even if you do not have the background for it. You may be a IT, accounting students, or a bio student, or a business student. Doesn't matter. Okay, non-IT faculty, we are opening this competition up today. A lot of y'all are from those non-IT faculties. Having said that, we also focusing more on the computing and the engineering students, because you have the necessary prerequisites. You have those programming subjects already embedded in your curriculum. You have some background in it. So even though Python is new for you, you may have learned C, Java, or some other language, but that will give you a head start, right? So yes, it's open to everyone, but computing and engineering students, you have the background for it, right? Okay. So this competition will be done at the university level, and the top 5 teams will go on to represent the university at the national level. Yeah. So at the university level, we will recognize the top 5 teams. The top 5 teams, and each team there will be 2 members, 2 people to a team, right? And during the competition, you will be having 2.5 hours time frame, and you will need to solve 8 coding challenges. And these coding challenges are not fill in the blanks. It's not ABC multiple choice. No, yeah. It is scenario based. It's real world scenario based. You will need to understand. You need to understand the scenario and then identify where in it is the problem, and then you need to attempt the question. So I think today our instructor JK will go a bit deeper into the eBox platform and to show you how you can able to troubleshoot, how you apply logic, and so on and so forth. So the top 5 teams will go on to represent the university at the national level. So the national level will be held in a host university in central region. Yeah. So that's the structure of the competition. So right now the pre-competition is going on. After the pre-competition, there will be the university level competitions. We will inform all of you when is your university competitions are. I think all of you already know about it, right? Different universities have got different days. Yeah. And then of course the national level competition will be in the August, right? So anyway, I think that's enough introduction for today, just to get you all started. We don't want to waste so much of time. We want to go get into the subject matter for today, which is the continuation of the day 1 sessions. Today is day 2. Once again, I would like to welcome our instructor, Mr. JK.
Hi, sir.
All right, so have fun, guys, and I'll see you towards the end of today's session. Thank you.
Thank you so much, sir. So let me continue the session. I'm sharing my screen. Yeah, good evening, all of you. So let us continue today's class. Let me revise on the topic that was covered yesterday, a quick revision. So I started with why we need to learn Python programming, or why we basically need a programming language. Okay. Then what are the different levels of languages? Okay. And how a compiler or an interpreter works. And why are we going for Python language? And yeah, then we got into the Python language. So what are the different data types in Python? Okay, number type and sequence type. And how does Python do dynamic typing? Okay. And we also saw what is the comment statements, how to do comments, and then these are the examples of how dynamic typing happened and how to take input from the user and then print it, and then the different output formatting statements. So how to format with different output formatting statements. One was the, the positional formatting, and the other was the named formatting. Okay. And then he started with operators. Okay. And we saw what is an expression, and we saw the different arithmetic operators. We also saw how it will work with examples. Okay. And then we saw the relational operators and then the logical operators. And we also started with the bitwise operator. Okay. So this is a quick revision. Sir, I suppose the session is being recorded. Gopal sir, the session being recorded. Guys, just give me a minute. So the session has to be recorded so that for your future reference it will be useful.
Recording in progress.
Yeah. So the recording has started. Yeah. So I've just briefed you about the yesterday's class. Okay. So let us continue with today's class. So bitwise operator. So with respect to bitwise operator, we saw about the AND operator, the OR operator, and the NOT operator. Okay. And I asked you a question yesterday, how a bitwise NOT operator work. Okay. So, or if A is equal to 5, what is not A? Okay, not A. So this symbol is used to represent the NOT operator, bitwise NOT operator. So how do you get that value? So this was my question. So anyone else has the answer for this? Yeah. So the first thing is inversion of the bits. That is correct. So A is equal to 5. So you can see this is the output. If A is equal to 5, this is the bitwise binary representation. And if you invert all the bits, you get not of A. That is fine. But I'm asking you, how did you get the value -6? I think I got the answer. So flip it and add 1. Very good. Invert the bits, use 2's complement. Very good. Yeah. So I'll explain it to those who doesn't know this answer. Okay. So what exactly happens is, so like if you declare a normal integer variable, it will be a signed variable. So what do you mean by a signed variable? You have two signs, right? Positive sign and a negative sign. Plus, sorry. And a minus. Okay, so these are the two symbols. Yeah, so these are the two symbols, right? So by default, if you give a value, so this a is equal to 5, right? So this is a positive number. So we need not mention any sign. So it is a positive number. So this is plus 5. Okay. So how does the compiler understand whether the given number is a positive number or a negative number? Okay, so it is nothing but the last bit. Okay, so the last bit represents the sign. Okay, if it is a 0, it means it is a positive number. If it is a 1, it is a negative number. Okay, I'll repeat it. If it is a 0, the last bit, if it is a 0, it is a positive number. If it is a 1, it is a negative number. Okay, so if it is a positive number, there is no manipulation. Directly, it will find out wherever there is 1 and like to just add the values here, you get the final decimal value. So here 1, 1. So this 1, this 4. So 4 plus 1 is 5. So output of this will be 5. So this is the direct answer. Whereas if it is a negative number, what happens is first you have to find the ones complement. Okay, so I request all of you to mute. Okay, so first I need to find the ones complement. So what do you mean by ones complement? So ones complement is nothing but flipping the bits 0 to 1 and 1 to 0. Okay, so that is the ones complement. So if I find the ones complement for this number, what will I get? So I request students to be on mute. ASEAN MD. So all of you kindly mute. Syed Rashid. Can you please mute Syed Rashid? Thank you. Yeah. So now finding the ones complement, just flip the numbers. 1, 0. Okay. And then find the twos complement. This is the ones complement. Now finding the twos complement. Twos complement is nothing but adding a 1 to the ones complement. Adding a 1 to the ones complement gives you the twos complement. So if I add 1, what will be the output here? So 1 plus 1, normal addition, it gives 2. Whereas here, this is binary addition. So what is 1 plus 1 in binary? 10. Very good. So it is 1, 0. So we take the 0 and the 1 will be carried. Okay, we take 0 and 1 will be carried. So carrying means what? This 1, whatever comes here, will be added with whatever number is present here. So 1 plus 0 is 1. Okay, and no more carries, right? So 1 plus 0 is just 1. So I put the 1 here. No more carries. So if there are no more carries, just take the present values and then put it then here. Okay, so this is the twos complement of this particular value. Okay, now what is the decimal value for this? So what is the decimal value for this binary number? 6, correct. Okay, so 2 plus 4. 2 plus 4 is 6. And since it is a negative number, okay, since it's a negative number, after finding the 2's complement, the decimal value will be added with a minus sign. Okay, so after finding the 2's complement, convert it to the decimal value and add a minus sign here. So this is how a negative number is being evaluated by the system. Fine. So let us see. Any doubts to this? I hope all of you understood the process. Any doubts, anyone? You want me to explain again? Yeah, fine, I'll do that. So, yeah, so this is your A, right? A is equal to 5. So this is the binary format of A. So what are we trying to do here is, we're going to find the knot of A. Okay, we are finding the knot of A. So knot of A is nothing but just inverting 0 to 1 and 1 to 0. Inverting the bits. Okay, inverting the bits. So you will get this, binary value. So how to find the value for this? See, one more thing I want you to understand is that all these processes you are not doing. Okay, so the system automatically does all these process for you. Okay, you're not doing any of this process. So just understanding what is happening inside. Okay, fine. So the first, what is happening here is knot of A is nothing but all the values are being inverted. Okay, zeros to ones and ones to zeros. So you will get this binary value. So this binary value, how it is being calculated is what is the process I have shown here. Okay, as I told you, the last bit represents the sign. So sign means what? Plus or minus. If it is a 0, it is a plus. If it is a 1, it is a minus. Okay. Now, since it is a minus, if it is a positive number, we need not do any process, or the system does not need to do any process. Directly it will calculate the decimal value, like how we were doing for these two numbers. Okay. So since it is a negative number, what happens is we need to find the 2's complement of that number. Okay, so what is 2's complement? 1's complement added 1 to 1's complement is 2's complement. First, we need to find what is 1's complement. 1's complement is nothing but inverting all the bits 0 to 1 and 1 to 0 is the 1's complement. Okay, so can you see we have inverted all the bits. Now, after finding the 1's complement, we are just adding a 1 to it. Okay, that is called the 2's complement. So, adding a 1 to it, what has happened? 1 plus 1 is 1, 0. Okay, this is binary addition. So 1 plus 1 is 1, 0. So 0 put here and we are carrying 1. So like how decimal addition works. So if any value greater than 9 happens, we just take the units place and then take the tens place to the carry forward, right? So the same thing is happening here. Okay, we have taken the first digit and the second digit goes as the carry. Okay, and again add these two numbers. 1 plus 0 is 1 and no more carries. Okay, no more carries. So just take the values and then put it here. So this is the 2's complement of this number.
Drop it outside of your seat. Yeah. Then drop the rest circuit. Yeah. You'll be in the downstream
We
block.
all please mute.
I'm sorry for the hassle. No. Hello, second bhai. तुम्ही आठटा पोझिशन ठीक एक्झॅक्टली ब्लॉकच्या नीचे
Guys,
आठटा
please
पोझिशन
mute.
ठीक आहे सर अच्छा ठीक आहे
Chow Coin. I request Chow Coin to mute. Okay. Okay, fine. So this is the 2's complement of not A. Okay, and then finding the decimal value for this will give you 6 and adding a minus to it is the final value. Okay, I hope you understood, right? Yeah, Muhammad bin Azari. Yeah, you are correct. So not of 6 will give you -7. So you can just do a calculation and see what will be the answer. And I can also execute it and show it to you. A is equal to 5, print of not A. Okay, so the answer is -6. Okay, so let me move on to the next thing. So we have two more bitwise actually 3 more bitwise operators. The next bitwise operator that we're going to see is the XOR operator. Okay, XOR operator. So what do you mean by this XOR operator? So we need to understand the truth table of XOR operator. So it is very simple. Anyone want to give a try? What is an XOR operator? Yes, very good. So if the symbols are same, you will get a 0. Okay, or a false. Okay, the symbols are same, you get a false. If the symbols are different, you get a true. Correct. Okay, so true, true, both are same, right? So you get a false. True, false, they are different. Okay, and then false, true, they're different. So it's a true. False, false, both are same. So it is a false. So very simple. If both are same, false. Both are different, true. Understood? Okay, so this is the truth table for XOR operator. Fine. So let us apply this to the bitwise operation. Okay, so there is no logical operator called XOR. Okay, so just the bitwise operator XOR is that, which is represented by the symbol cap. Okay, so above 6 you have the cap symbol, right? The cap symbol is used for XOR operation. So A XOR B. So A is this one and B is this one. So if you do XOR operation on each and every bit, so here 1 XOR 1, both the same, right? So I'll get a 0, 0, 1, they are different. So I'll get a 1, 1, 0, again they are different. I get a 1, 0, 1, different, so 1, 0, 0, same, so 0. So all others are zeros, so 0, 0, 0. Fine. So this is your XOR operation. So can you tell me what is the decimal value for this? So what is the decimal value? Is it 16? 8 plus 4 plus 2. It is not 16, it is 14. Yeah, great. Okay, 8 plus 4 plus 2, it is 14. Okay, fine. So this is the XOR operation. Next operation that we're going to see is, let me take this value and paste it down because I have to do some calculation. Next is the left shift and the right shift. Okay, first let us see the left shift operation. So, yeah, so this is the left shift operation. Okay, and I'm going to give an integer value after this left shift operation, which means that how many times I need to shift. Sorry. So if I, sorry, it is auto capitalizing. Let me do a capitalizing here as well. Okay, so A is 5. So A left shift 1. Okay, so this 1 represents how many times I'm going to shift the bits. And this arrow left side represents I'm going to do a left side shift. So what will happen to the last bit? So this is the first bit, this is the last bit, right? So we usually call it with the terms LSB and MSB. LSB is least significant bit and MSB is most significant bit. Okay, LSB least significant bit and MSB most significant bit. So least significant bit being the bit at the 0th position and most significant bit being the bit at the last position. Okay, whatever it may be. So this is the 8-bit representation. So this is the 7th index, right? So the bit at 7 represents MSB and bit at 0 represents LSB. So what will happen to the MSB if I do a left shift by 1? So is there any bit in the left hand side? No, right? So there is no bit in the left hand side. So what will happen is the bit that is going out of the boundary will get discarded. Okay, it will not get circularly added. Okay, it will get discarded. Okay, whatever bit is here, either it is 1 or 0, it is going to get discarded. Okay, and following that whatever bits are there will be moved to one step towards the left side because it is left by 1. Okay, so this bit being discarded, what will happen to the 6th bit? It will move to the 7th position. 5th bit we move to the 6th position. Likewise, it happens till the 0th bit moving to the 1st position. Okay, and what will be there in the 0th bit? After moving the 0th bit to the 1st position, the 0th bit would be empty, right? So what would be there after moving? Very simple, there would be 0. Okay, so if I move all the bits one step towards the left hand side, I will be getting 0, 0, 0, 0, 1, 0, 1, and finally at the 0th bit I'm going to add a 0. And you have to be clear that this is not the bit coming from the 7th digit. Okay, not from the 7th position. So this is not the bit coming from the 7th position. This is a new bit which is being added. So there is no circular shift happening. This will get discarded and new bit will be added. Okay, fine. So what is the decimal value of this binary value? 10. Very good. So 10 is the decimal value. So if I do a single left shift, okay, if I do a left shift twice, okay, so what will be the output? Can anyone give me the binary value? What is the binary value of A left shift 2? Yes, very good. So it is 0, 0, 0, 1, 0, 1, 0, 0. Okay, so this is the decimal representation. And the sorry, this is the binary representation. And the decimal value for this is very good. Some of you have already told, very good. So it is 20. Fine. Now let me do one more calculation. A left shift 3. So obviously the value is going to be 0, 0, 1, 0, 1 followed by 3 zeros. Okay, so what is the decimal value? 40. Yes, you're right. So for others to do a fast calculation, I'm just copying all these values. Okay. Okay, I'll put it here. So here, so what is this? 2 plus 8. Okay, for A left shift 1, it is 2 plus 8, 10. And then A left shift 2, it is 16 plus 4, which is 20. A left shift 3, 32 plus 8, which is 40. Okay, so can you see what exactly is happening? Okay, let me write one more step. What is A left shift 0? What is A left shift 0? Yes, very good. So it is the same value. Okay, so we are not shifting at all. So 0 times shifting is nothing but the same number, right? So the value is 5. So you can see for every shift, the values are getting doubled, right? Can you observe that? For every shift, the values are getting doubled. Can you tell me what will be the value of ALF shift 4 without finding the binary value? Without finding the binary value, can you tell me the decimal value? Yes, very nice. So it is 80. So this a pattern is being followed, right? 5, 10, 20, 40, and then 80. Got it? Okay. So now we have to like, can we arrive with a formula what exactly is happening using shift operation with respect to the first value, with respect to the initial value? Yes, very nice. So A left shift n is nothing but A into 2 to the power n. Okay, it is nothing but left shift n is nothing but A into 2 to the power n. Okay, so can you visualize this? See, suppose if A left shift 0, what does it mean? A into 2 power 0, right? Okay, so first the power operation will be happening. So because of the precedence, okay? So for power, precedence is high. So first the power operation happens. Understood? Okay, so 2 power 0 is 1. So 5 into 1 is 5. So A into 2 to the power 1. So 5 into 2 to the power 1 is 2. So 5 into 2 is 10. So likewise it goes on. So 5 into 2 to the power 2. So 5 into 4 is 20. 5 into 2 to the power 3. 5 into 8 is 40. 5 into 16 is 80. So likewise it goes on. Fine. So this is what is happening in the shift operation. Now tell me, with respect to computation, whether shift operation is better or calculating this particular expression is better. I'll repeat the question. Comparing these two expressions, whether shift operation is better or performing this expression is better. Yes, shift operation, expression. Few of you are saying expression, and some of you are saying shift operation. Actually, the answer is shift operation. Why? Because this is considered as a single operation. Okay, so all these operations you are not going to perform, the system is going to do it. Whereas if you take this particular expression, what all operations you need to do? You need to multiply to n number of times, even though it happens through the system, all these operations happens, right? A into 2 to the power n. Okay, so 2 power n is, suppose if it is 2 power 4, you have to multiply 2 4 times and then take that value and multiply it again with a. So these many operations are going to happen in this expression. Whereas here, it is a single expression. Okay, so this is called optimization. Okay, so in most of the places, this shift operation plays a major role in optimization. Okay, so I will give you certain examples in the tomorrow's or day after tomorrow's class where the shift operation plays a major role in optimization. Okay, so this is one example. So where if you find any of the problems which contain this kind of an expression, don't do this. Just do a shift operation. Both the values are going to be the same. Okay, fine. So this is your left shift. Okay, for right shift, I will give it to you. Okay, you just do the calculation and tell me what would be the equivalent expression for a right shift n. So for left shift it is a left shift n is nothing but a into 2 to the power n, right? Similarly, what is a right shift n? Yeah, correct. So we are shifting the bits towards the right. My question is, what is the equivalent expression? So can you see the expression here, a into 2 to the power n, which is for left shift, right? Similarly, for right shift, what is the expression? Yes, very good. You have given the answer. Instead of multiplying with 2 to the power n, it is division by 2 to the power n. Okay, and it is not normal division; it is floor division. Why? Because we are not going to get any decimal values. Okay, we are not going to get any decimal values. We're just going to get the whole numbers. If you want decimal values also, this particular shift operation is not going to work. Okay, only this expression is equivalent to a right shift n. Understood? Any doubts so far, anyone? Okay, fine. Thank you. So this is all about the bitwise operations. Okay. So next we will move on to the next operator, which is the assignment operator. So assignment operator is nothing but the equal to symbol. Okay. So for example, if you take a equal to 5, so this is the assignment operator. As the name suggests, assign. So you're assigning some value to a variable. So that's where you use the assignment operator. Right? Simple, right? Okay. So this is the assignment operator. Along with the assignment operator, you have some certain shortened notation. Suppose you want to perform an operation called A is equal to A plus 2. Okay, suppose if you want to perform an operation like this, A is equal to A plus 2. So here what exactly is happening? You have the value A, okay, which is 5, adding 2 to it, and again assigning the same value to A itself. So the final value of A is going to be 7 after this step. Okay, you're just updating the value of A by adding 2 to it, right? So this can be equivalently written like A plus equal to 2. A plus equal to 2. So you should not be confused with A equal to plus 2. So this is totally wrong. This is totally different. This is not wrong actually. This means what? This particular statement means you are assigning 2 to A. Okay, so for better understanding, what I'll do is I'll execute the code and show it to you. Initializing A is equal to 5. I'll put a lot of print statements. Okay, first I'm printing A is equal to first A plus 2. Obviously, we know the answer is 7. Okay, A is 2 and A finally after updating A is 7. Okay, let me comment this and I'm going to put A plus equal to 2. Now I'll save the code, execute it. Now you can see the same value, 7. Okay, so both the expressions are equivalent. Now again I'll do a comment. I'll comment this A is equal to A equal to plus 2. Okay, I save the code. Now I execute and I can see that final value of A is 2. Understood all of you what is happening here? So this and this are different. Okay, don't get confused. A plus equal to 2 is nothing but updating A by adding 2 to it. A equal to plus 2 is nothing but assigning 2 to A. Got it? So this particular shorthand notation, this is called the shorthand notation, plus equal to. Okay. So for any arithmetic operation, this can be performed for subtraction, multiplication, division, modulo, okay, power operation. So for anything, this particular shorthand notation, this is called shorthand notation, can be used. Okay, fine. So I'm not getting much deeper into it. Hope you understood. Okay, we move on to the next topic. Next operator. So we have two more operators. These are specific to Python. Okay, one is the identity operator. So there are two identity operators. One is yes, and the other is not. Okay, is and is not. So like yeah, so I'll explain you how this is and is not works. A is equal to, I'm giving a string apple, okay, and B is equal to orange. If I print A is B, okay, so what do you think will be the output for this? It is like English, right? False. Very good. So just asking a question, is A equal to B? Okay, simple. A is B is nothing but it is a wrong statement, right? So obviously you'll get a false. Okay, you'll get a false. Suppose I give apple. Now what will be the output? True. Very good. Because apple is apple. Now next, let me change the values. Let me give integers. Okay, A is equal. Let those I just commented. A is equal to 123, B is equal to 123. Print A is B. Now again the output is going to be true, right? So you're getting a true. So both the numbers are same, true. And what if I give is not? Okay, A is not. Correct. So I'm going to get a false. Right? So this is till this it is perfect. Okay. Let me give two more values. C is equal to, I'm giving a list. So you don't know about list, don't worry about that. I'll explain it much deeper. Do it. D is equal to 1, 2, 3. Print P is D. So what do you think would be the output for this? True. Okay, it is executed and the system says it is false. The system says it is false. Okay, just make a note of it. I'll explain this in detail in tomorrow's class, because you need to understand how the memory allocation for list happens in detail. Then only you will be able to understand why these two values are not the same. Okay, just make a note of it in your notebook. Tomorrow I will explain why C is D is giving a false. Okay, fine. So if I explain that, you will get the answer why for Apple alone it is coming correct, for integers alone it is coming correct, why not for list? Okay, even for that you will get the answer in tomorrow's class. Okay, fine. So this is identity operator, is and is not. Next, the one more operator is there in Python, which is called the membership operator. Again, in membership operator, you have in and not in. Okay, you should see the difference here. So for identity, it is and is not. Okay, after is, you have a not. Okay, whereas in membership operator, you have in and not in. After not, you're getting an in. Okay. So, like, if I write the statement, you'll understand this as well. So, A is equal to app, okay, and B is equal to apple. Print A in B. So, what do you think is the output for this? True, right? So, from the statement itself, you are able to understand, right? App. So, this A is nothing but this app. B is nothing but this apple. So, you can clearly see that app is in apple. Okay, that's why it is a true. I execute the code and show you. Can you see a true here? Okay. And now, so for any substring you give, you're going to get a true here. Okay, let us test with PL. Okay, is PL in apple? Is PL in apple? Yes, right? So you'll get a true again. Fine, for any substring it is going to work. So this is called the membership operator. Okay, this can be used in list as well. For list, I'll give you a clear understanding in tomorrow's class. Just for example, I'll give you one program. Okay, so A is equal to 1, 2, B is equal to A is equal to 2. Print A in B. Okay, I save the code, I run it, I'm getting a 2. Okay, just checking whether a particular value is in a list. Understood? And the exact reverse of this is not in. Okay, not in. Okay, so 2 not in this 1, 2, 3, 4. So this is a false. Very good. So it is a false. So these are the different types of operators in Python. Any doubts in operators? No doubts? Okay, fine. Let us continue with the next topic, which is the control statements. So this is going to be interesting. We'll see a lot of examples, and I will give you a quick exercises as well, then and there. Okay. So if you have the system with you with a Python compiler, this will be much more easier for you to answer. If not, you can also open the online Python compiler. Just type online Python compiler. You will get a lot of online tools. Okay, so where the Python code can be compiled. Okay, and get the output there itself. So yeah. So control statements. So control statements is like a brain of a program. So it is going to control the flow of the program. Okay. So for example, whether to take a particular path or not. Okay. So particular set of statements, how many times it has to be executed. Okay. Whether that should be executed or not. So making such decisions are going to happen in this particular part. Okay. So that's why I call it as the control statements. So these control statements are divided into three types. One is the conditional, second one is the looping, and third one is the non-conditional control statements. Okay, so we'll have a deeper look at these different control statements. Okay, the first one being conditional statements. Okay, so conditional statements. So in conditional statements, the first thing which you're going to see is simple if. Simple, sorry for the spelling mistake. So simple if. So I will straight away give you the code so that from the code we can understand the syntax. Okay. So this is an example which will take the input, which is the soil moisture. Okay. And it is going to check whether the soil moisture is less than 30. So this is a threshold. If it becomes less than 30, then I have to perform a task which is nothing but just inform the owner that the soil is dry. Activate the water pump. Okay. So this particular statement will get executed only if this condition is true. Okay. So soil moisture, I'm getting an input. Okay. So this input can be taken from any sensor. Okay. You have a soil moisture like recognition sensor. Okay. So this will take the input, observe the temperature and give it to the system. If the soil moisture is less than 30, so you're going to activate the water pump. Okay, that's it. So this is the simple if. Can you see the condition if? Okay, so this is syntax if followed by the condition, and the most important thing is this colon. Okay, the colon everywhere represents the start of the block. Okay, okay, start of the block. So what do you mean by a block? So block is nothing but a set of statements. Okay, a set of statements is called a block. So under this if condition, there is a set of statements. Okay, so let me put it in two different print statements so that it becomes two lines separately. Okay, soil is dry, activate the water pump. And some print statement stating thank you. Okay, fine. So what does this tab space indicate? So you can see some space present here, right? So this space indicates that, okay, all these statements following this space belong to this if condition. So if this if condition is true, so certain statements has to be executed, right? Those statements are nothing but these two statements, which are followed by the tab space. And you can see the third print statement doesn't have a tab, right? There's no space before the print, which means that this does not belong to the if statement, okay, if condition. This is something out of this if condition. So till this point, it is the if condition. After that, it is the normal program. Okay, so let me run the code and show it to you. So it is waiting for the input. Let me give 25. Okay, so if I give 25, what is happening? It is checking the condition. The soil moisture is less than 30, right? So it is printing the soil is dry and activate the water pump. If it is not, let me execute it again. And if I give the soil moisture as 50, and it says yes, thank you. Can you see the thank you statement present over here also? Okay, which means that after the end, after this if condition is statements are over, okay, the regular statements get executed. So this print thank you is a regular statement. Okay, so here since the condition is false, the statements which are present inside the condition are not getting executed, and the regular statement has got executed. So that's why you got only a thank you here. Okay. And the most important thing is in Python, the blocks are not represented using curly braces. Okay, in C, C++, Java, wherever the other languages uh, preceding Python, were using brackets for blocks, right? So these flower brackets were used for blocks. In Python, we are not going to use these brackets for blocks. These brackets have a different meaning. Okay, they are called the dictionary. Okay, fine. Dictionary can be seen later. Now, you need to understand that blocks are represented using the tab spaces. Okay, some space. Okay, it can be 2 space or 4 space or 8 space. The thing is that has to be followed for the entire program. Okay, so if you give 4 spaces here and if you separate this with one more space, okay, this Python program is not going to run properly. It will throw an error. Okay, so every statement belonging to the block should have the same indentation. So this space is called indentation. Okay, fine. So this is the simple if. Next is the if else. Next is the if else. Excuse me, just give me a minute. Yeah, I'm back. So next is the if else. Okay. So let me give the example directly to you, and I'll explain. Okay. Suppose you have a music system that recognizes your emotions. Okay. Suppose you're getting the mood, it recognizes your mood. If mood is equal to happy, okay, then playing a pop song, a pop music. Okay, if you're not happy, means then playing a calm music. Fine. So this is a simple if else statement. Okay, you're getting a mood from. So this input can also be an input recognized by the sound system. Okay, and so based on the behavior, it recognizes your system, it recognizes your emotion. If your mood is happy, it plays a pop song, else it plays a calm music. Okay, so if it is happy, so it says playing a pop music. If sad or some other any other emotion, okay, it plays a calm music. So this is just a simple if else. Okay, fine. So here what is happening, if some condition, if it is false, immediately what happens, it will go to the else part. Okay, if one condition is false, it goes to the else part. That's why it is called if else. Fine. Next, moving on to the next conditional statement. Which is the cascaded if elif else. Okay, cascaded if elif else. Again, I'll give you an example and then I'll explain it. Okay. Suppose you have an automated a robot that cooks. Okay, automated robot that cooks, and you have to supply the main ingredient to it. So based on the main ingredient, you are going to decide what dish to prepare. Okay, so if main ingredient equal to tomato, then cooking tomato soup. Okay, and then So here else and if we should not use. Okay, that is a term called elif. This is a keyword, so you have to use elif. Okay, that is nothing but else if. And one more important thing that has to be noted here is we are not using the brackets to mention the condition, right? We're not using brackets to mention the condition. So actually it is not mandatory. If you use brackets, that is good. Okay, for better understanding, we use brackets, right? But Python actually doesn't need the brackets. When the brackets are necessary is that if you have multiple statements, multiple expressions to be evaluated. Okay, if you have multiple expressions to be evaluated, in that at that point of time, you'll be making use of the brackets. Okay, so this is a simple condition, right? So this need not be enclosed in brackets. We have 2-3 conditions, and if we want to give some priority to those conditions, then we make use of the brackets. So for simple conditions, we need not give brackets. If you give brackets, that is fine. Okay, that is up to you. Okay. If main ingredient is equal to potato, making crispy fries. Okay. Milk ingredient is equal to paneer, print preparing paneer tikka. Okay, and these are the instructions that are given to the robo cook. Okay, if if it doesn't find any of these ingredients, then it would say a sorry to you. Sorry, I don't have a recipe for this ingredient. Okay, so whatever input you're going to give, it will try to match with these inputs: tomato, potato, paneer. No space here. Okay, so if it matches, then you get the corresponding dish. If not, it is going to say a sorry to you. Yeah, so this is the cascaded if else. Okay, let me give the input: tomato, and you can see cooking tomato soup. This is the output. I execute it again, put paneer, preparing paneer tikka. Now I give rice, and it says that sorry, I don't have a recipe for this ingredient. Understood? So this is called cascaded if else. Okay, so if else, and finally you will end up with an else. So what does this else mean? If none of the conditions become true, finally the else part will get executed. Okay, fine. So this is also called if else ladder. Okay, if else ladder. Can you see the formation of a ladder here? Okay, so that's why it is called if else. It is also called if else ladder. The main term is cascaded if else. Okay, it is also called as the if else ladder. And this is the syntax for the cascaded if else. Any doubts so far? Okay. So the final conditional statement which you're going to see is the nested if else. Nested if else. Again, let me give you the example. Suppose you have a security system installed in your house, okay, which has the face recognition and the PIN code or the passcode has to be entered. Okay, fine. So is recognized equal to, so you're going to get an input true or false. Okay. And then passcode, correct. So do you understand why I am giving a bool here? I'm giving a bool because I'm going to convert the input to a boolean value. So the inputs are going to be true or false. Okay, the inputs are going to be true or false. So we have a face recognition system that says whether the face is recognized or not. And we have a passcode. So if the user enters the passcode, it checks whether the passcode is correct or not and gives the output. Okay. So we have two systems, suppose, and we have the inputs from those systems. The person inside the house only if both the face and the passcode are correct. Okay. If face is recognized, okay. If passcode is correct, then you will give access. Okay. Access granted. And you can also print some welcome statement. Welcome home. So here, what is happening here? So if face recognized, only if face recognized is true, it will enter inside to the next step, right? So if passcode is correct, then access is granted. If passcode is wrong, okay, if passcode is wrong, I will print the face is recognized, but incorrect passcode. Understood? Here, what does this particular else statement mean? The face is recognized. Only if the face is recognized, you will get enter inside this particular block of statements, right? And then you're checking whether the passcode is correct. If face is recognized and the passcode is correct, then access granted. Okay. If the passcode is wrong, face is recognized already, right? So face is recognized, but it is an incorrect passcode. So what if the face itself is not recognized? So if the face itself is not recognized, I'm not going to get the passcode from the user. Okay, straight away I'm going to tell unknown face. Okay, unknown face. So access is denied. Okay, so here what you have to understand is the number of indentations happening over here. So can you see for this print statement, I have two indentations. Okay, two indentations, which means that this particular statement belongs to the inner if condition. Okay, and this print statement belongs to the else part of the inner if condition. And you can see, can you see there is no tab space, it is coming along with this if condition, which means that this particular else belongs to this if condition. Okay, so there is no tab. So this else belongs to this if condition. This else belongs to this if condition. Okay, and the tab spaces are given accordingly. So you can also do one more check and then you can nest it on one more. So you can do a one more nesting as well. So this is called a nested. Okay, one inside the other, one inside the other. This is called nested if else. Okay, understood what is nested if else? Any doubts, anyone? Okay, fine. So we can also write if else in one more format, which is called the conditional expression. I'll show you how to do that. Okay, suppose you're getting a temperature. Okay, so I'll explain. I'll give an example again and then explain. Getting a temperature. And then, so giving an alert. The too hot if temperature greater than 30, else comfortable. Okay, and finally print the alert. So this is just like reading English, right? So just read it. Too hot if temperature is greater than 30, else comfortable. Okay, so this is how this conditional expression works. So like what happens here is this particular value will be taken if this condition is true. Okay, so this particular value will be taken if this condition is true. If the condition is false, after the else part, we have a statement that will be taken. Okay, so this kind of expression is used when a single line has to be implemented if the condition is true, and a single line has to be implemented if the else part is if the condition is false. Okay, if there are multiple lines, this doesn't work. If single line values have to be like evaluated, okay, then you can go for this kind of expression. Okay, have you understood this? This is called the conditional expression. So let me execute this and show it to you. So I'm going to enter a temperature 40. So it says too hot. Okay, I'll give 25. It says it is comfortable. Okay, fine. So this is called conditional expression. So it is a single line if else statement. That's it. Okay. Fine. Next, we'll move on to looping statements. So those who are familiar with C, C++, and Java, okay, if those are familiar with C, C++, Java, you would have studied about switch statement, right? In Python, there is nothing called switch statement. Wherever you want to use switch statement, you need to go for this cascaded if else. So this particular syntax has to be used for the use case of switch case statement. Okay, fine. And one of you asked the question, can you tell me when to use conditional expression again? Yeah, see, okay. So just take this particular case itself. So can you see there's a single statement, okay, inside this condition and a single statement in the else condition. This particular statement can be converted to the conditional expression like this. Okay. Music is equal to. So I'm not writing the entire print statement, just taking I will pop. Okay. So pop if mode is equal to happy. Else calm. Understood? I've converted this entire if condition to a single conditional expression. So I copy this, I can execute this and show it to you as well. And you can print the music. No, not in the request. So now let me execute the code. Happy pop. Okay. So this is the use of conditional expression. Understood? Yes. Any doubts? Okay. Next, moving on to the looping statements. So in loop, we have two kinds of loops. One is the for loop, and other is the while loop. Okay. So in Python, there is no do while loop, only for loop and while loop. Okay. So we need to understand the uses of for loop and the use of while loop. Okay. So we'll see one by one. The purpose of for loop is very simple to iterate over sequence types. Okay. So what is the sequence type? The first class we saw, yesterday's class we saw, right? The two types, the sequence types, the different sequence types. So these are the different sequence types. To iterate over these sequence types, we make use of the for loop. Okay, we make use of the for loop to iterate over the sequence type. So this is the sole purpose of the for loop. And while loop is used for performing the normal looping operations. Okay, so first let us finish this for loop, then we'll come to while loop. So for performing some operations on for loop, so we haven't seen about the sequence types, right? We don't know what is a list, what is a tuple, what is a set, what is a dictionary. So before going to that, we should understand there is a function called a range. Okay, a function called range, which is called a sequence generator. Just called the sequence generator. So I'll give you certain examples of range. So this is a function. Okay. So range can be used in three different ways. Okay, one is with a single argument. So range of 5. Let's suppose range of 5. So this particular range of 5 function will produce a sequence which will contain the values 0, 1, 2, 3, and 4. Okay, so range of 5. Okay, it is a function which will generate a sequence for us. The sequence is nothing but 0, 1, 2, 3, and 4. Okay, and the second way of using range is using two arguments. One is the start value, another is the end value. And we have to be clear that the start value is inclusive. The start value is inclusive, but the end value is not inclusive. So this particular range function will produce this sequence. Okay, so 2, 3, 4, 5, and 6. This is the sequence generated by this range function. The first argument is the start, the second argument is the end. And there is one more way in which range function can be used, which is giving 3 arguments. Okay, 2, 10, 3. So here, what is the purpose of these 3, or what is the what does these 3 values represent is that first one is the start value, the second one is the end value, and the third one is nothing but the step size. Okay, the third one is nothing but the step size. So step size is nothing but how many values has to be increased. Okay, between the numbers, how many values has to be increased. So the starting value is 2, right? So the next value is going to be 3 plus the previous value, okay, which is nothing but the 5. And so again, what would be the next number? 3 plus 5, which is nothing but 8. What would be the next number? So next number should be 11, but 11 is not within the range, right? So 2 to 10 is not within the range. So the output of this is going to be 2, 5, and 8. Okay, so these are the 3 different ways in which the range function can be used. Okay, fine. So yeah, so I'm going to use this range function in for loop and show you what will be the output. So for I in range of 5. Okay, for I in range of 5, and I'm going to print I. Can you see the output? 0, 1, 2, 3, and 4. Okay, so if I use range of 5, I get this output. And if I use 2, 7, I'm just replacing this value with 2, 7. And can you see the output? 2, 3, 4, 5, and 6. And 2, 10, 3. Now if I execute the code, I get 2, 5, and 7. Sorry, 2, 5, and 8. Okay, understood? So this is the output of third way in which the range function can be used. So any doubts in this range function? So this is a very important function because this will generate a sequence for us. Okay, it is going to generate a sequence for us. Okay, so I'll ask you a question. So I want to print the numbers 7, 6, 5, 4, 3. So I want to print the numbers 7, 6, 5, 4, 3. So what should be the range parameters? So how should be the range function and its parameters? Anyone? Yes, very good. So 7, 2 minus 1. So it is also to be noted that the step size can also be a negative number. So if I give the step size as the negative number, so range of 7, 2 will not work. Okay, because the default step size is 1. Okay, here we haven't mentioned the step size, right? So default step size is 1. Okay, so the correct answer is range of 7, 2, minus 1. Okay, fine. So why are you going till 2? Why not till 3? So why are we going till 2? Why not 3? Yes, because the end value is exclusive. Okay, it is not included. So it is excluded. Fine. So that is why we go till 2. See, from starting from 7, okay, 7 minus 1 is 6. Again, 6 minus 1 is 5. 5 minus 1, 4. 4 minus 1, 3. Okay, and then the next number is going to be 2, right? So 2 should not be included. So I stop till 3 itself. Stop at 3 itself. Okay. Let me execute the code and show it to you. Okay, so the value is 76543. Good. So we have understood that negative numbers can also be used as the step size. Okay. And okay. So this is about the single loop. Okay. So we will see certain examples. Okay, we are going to print the number series. Okay. Fine. So can you tell me the logic? Okay. So let me like give us. Let me set a standard. Okay. So I'm going to take an input n. Okay, which is nothing but the number of outputs I need. Okay, n is nothing but the number of outputs I need, number of numbers I need, for example. And then for I in range of n. Okay, so the first series which we are going to generate is the square series. Okay, so which is nothing but 25, 49, 81, 121, 169, and so on. Okay, so you should make use of these two statements. Okay, so this n is nothing but the total number of numbers. If I give n as 3, I want the output only 25, 49, and 81. If I give the n as 4, I want these 4 numbers. 5, these 5 numbers. 10, I want to generate the 10 sequence numbers following this sequence. 10 numbers which follows this sequence. So can you tell me the logic for this particular sequence? Yes. Can you tell the logic for this sequence? So you can use any number of initialization values. Okay, so you can use temporary values. Okay, and then use those temporary values to do the calculation, and then you can also print. Okay, for this particular example, I'll tell you okay how this is happening. So this is nothing but 5 square. I am using cap symbol for square for simplicity. Okay, and this 49 is nothing but the 7 square. 81 is nothing but 9 square. 121 is nothing but 11 square. And 169 is nothing but 13 square. And it goes so on. The next number is going to be what? What is going to be the next number? Good. This 15 square. Okay. So basically what I need is this particular series. 5, 7, 9, 11, 13, 15. Like that it goes on. Okay. So for every time it is getting incremented by 2. So I need not use the for loop for getting incremented. So this for loop is going to run the total number of times I want the total number of outputs I want. Suppose I want 5 outputs, okay, 5 numbers from the series, this loop is going to run for 5 times. So don't touch this loop, okay? Use temporary variables, that is well and good. So the first temporary variable I'm going to use is a, which I'm going to initialize it as 5. Okay. So what is going to be printed is a square. Okay. And how much should I increase a? I should increase a by 2, right? I should increase a by 2. So just put a plus equal to 2. That's it. This is done. So I'm getting an input from the user, which is nothing but the number of number of elements I want from the sequence. Okay. And then I'm initializing as 5. Okay. I'm running a loop for n number of times. And then this is the logic to find the sequence. Okay. Printing a star, a double star 2, and then incrementing a by 2. So let me execute this code and show it to you. So I want 5 numbers. So these are the 5 numbers: 25, 49, 81, 121, 169. So I want 10 numbers. So I got these 10 numbers. So whatever number I give, so those many numbers will be printed. Understood? So this is how you should make use of the for loop for generating the sequence. Okay, so in the chat I have a loop, a question. So what about for I in range of 5, 30, 2, print I star I. See, what would happen in your case is that the values from 5 and 30 alone will be printed. Okay, so I will not be able to generate a sequence of 100 numbers or 200 numbers or 1 number or 2 number even. Okay, so it is a defined range. Okay, only 5 to 30, the values are going to be printed. So if I want a customized range, then I have to go for this kind of statement. If it is a defined range, then your output is, your program is correct. If you want a customized range, then you have to go for this kind of looping. Okay, fine. So I'll give you some more exercise. So can you generate a sequence like this? 4, 18, 48, 100, 180, and so on. So take a paper and then think about the sequence. You don't use any external websites or GPT. Okay, so don't do that. Just try to work out and tell me what is the sequence? What is the logic behind the sequence? Yes, anyone? Shall I tell? Okay, I'll tell the logic. You tell me the program, how to do the program for this. Okay, so the logic is very simple. 2 power 3, that is nothing but the 2 cube minus 2 square. So this is the first number. The second number is 3 cube minus 3 square. Okay, the third number is 4 cube minus 4 square. Okay, and the fifth number is obviously 5 cube minus 5 square, and so on. Okay, this is the logic. Fine. So what is this? What is 2 cube? 2 cube is 8. Okay, minus 2 square is 4. So 8 minus 4 is 4. 3 cube is 27. Okay, and 3 square is 9. So 27 minus 9 is 18. Okay, 4 cube is 64 minus 4 square is 16. Okay, so 64 minus 16 is 48. Similarly, 5 cube minus 5 square, 6 cube minus 6 square, and goes on in this. Okay, fine. So how to write a program for this? Make use of this n input and the loop. We'll comment this. Yes, how to convert this loop into a logic? No. Yeah, correct. So you have to initialize a as 2, and then you have to print a cube minus a square. Okay. Yeah. So it's very simple. A is equal to 2. Initializing a is equal to 2, and then print a cube minus a square. And then the next time a should be incremented by 1. Okay. So a plus equal to 1. So can you see I'm using the shorthand notations to update? Okay, a, the same value a has to be incremented by 1. So a plus equal to 1. So in the previous example, the same value a has to be incremented by the value 2. So a plus equal to 2. Fine. So this is the logic. So let us execute this code and see. I give 5. So I get the output. So 4, 18, 48, 100 and 180. Okay. And I give 10. I get 10 numbers. Okay, fine. Okay, so one more example. So try to figure out the logic behind this sequence. Okay, so 11, 12, 15, 20, 27, and so on. So I'll give you 1 minute time. Try to find out what is the logic behind the sequence. One plus 2n. What is n? Yes, very good. So the answer is +1, +3, +5, +7 to the previous numbers. Okay, so this is the first number is 11. The second number is nothing but 11 plus 1. And the third number is, the previous number is 12, right? So 12 plus 3. Okay, and then I'll use spaces to for better understanding. So what is this 20? Which is nothing but 15 plus 5. And 27 is nothing but 20 plus 7. Good. So this is the logic. Can I tell the program for this? So a plus equal to 2 doesn't work because it's not getting incremented only by 2, right? So the increment value is getting increased every time. Yes, anyone? Yes, very good. I got an answer. Let us see whether it is correct or not. Okay. See, actually, for this particular sequence, to generating this particular sequence, we need two values. Okay, in the previous examples, we are using only one additional value, right? Here is equal to 2, here is equal to 5, only one additional value is used. Whereas here, we need two additional values. Why? Because one is going to manage the sequence, one is going to manage the sequence, and the other is going to manage the increment value. How much is it going to get incremented? Okay. So the initial value can be assigned with A. Okay. And the incrementing value. So the value used to increment. So can be used as J. Okay. Fine. So first, what I should do is, once I enter inside the loop, I print the value of A. And I prepare the value of A for the second iteration, for the next iteration. So what it has to be? It has to be A plus equal to J. Okay. So which is, yeah. So which is nothing but, so I will also write the expansion so that it will be clear for you. A equal to A plus J. And finally, I increment J as well. Plus equal to 2. Okay. So why am I incrementing J every time with 2? Because of this. Okay, first it is 1, then it is 3, then it is 5, then it is 7, right? That's why I'm incrementing J every time twice. So let me execute this code and show it to you. 5. Okay, so I got 11, 12, 15, 20, and 27. So I executed 10, I got the 10 numbers. Understood? We have a look at the previous problem. Yeah. So this is the previous problem. And this is the current problem. So understood all of you? Any doubts in this? See, for practicing single loops, okay, you can take a mathematics book which contains a lot of sequence. Okay, just keep solving all the sequences. You'll be familiar with the single loop. Okay, fine. So next we'll move on to nested looping. So nested looping means what? A loop inside a loop is called nested looping. A loop inside a loop is called nested looping. The loop inside a loop can be in any combination. Okay, so it can be a for inside for. Okay, can be a while inside a for inside a while inside a while. So it can be any of these. So you can have multiple nestings also, for inside a for inside a for. Okay, so you can have 3 nestings also. So any number of nestings can be done. Okay, so simple nested loop is nothing but a for inside a for, or a while inside a for inside a while, or while inside a while. A single level nesting. So to understand these nested loopings, so we have to solve a lot of problems in the format of patterns. Okay, in the format of patterns. So let me solve a pattern for you so that it will be easy for you to understand nested looping. So the first pattern which you're going to solve is 0, 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. So this is a 4 cross 4 pattern. So pattern is always a 2-dimensional structure. Okay, so it consists of numbers, it consists of any special characters. Okay, so yeah, so you'll be seeing a lot of examples so that it'll be clear for you. So let me write a code for this, then I'll explain. So for I in range of 4, for j in range of 4, print j, separator is space, and print an empty print. Okay, so that's it. This is your code that will generate this particular pattern. So I'll execute it. And sorry, not separator, it is end. Okay, can you see this pattern? Now I'll explain the code. Okay, so here you have 2 loops. Okay, so one loop is iterated using the variable I, and second loop is iterated using the variable j. So we usually use the same like variables, the outer loop I, the inner loop j, and it goes on like that. Okay, k, l, m, like that. Okay, fine. So this I loop will take care of the rows. Okay, rows. So here there are 4 rows, right? That's why I am writing a loop that runs for 4 times. The I loop running for 4 times. So if I give a 5 here, okay, you can see the output. You got 5 rows. So what does it mean? the I loop is taking care of the rows, and this J loop is taking care of the columns. Okay, so every time the I loop runs, this J loop will take care of the number of times in that particular row, how many columns has to be printed. So it can be a varying pattern as well. The first line, this is a constant pattern where all the columns are having 4 elements. So there are certain patterns where the first will have only one output, the second row will have 2 outputs, third row will have 3 outputs, like that, it keeps on increasing. During that time, you have to carefully manage this J loop. So in this case, every row contains only 4 elements. So I'm writing a loop that runs for 4 times. Okay, for J in range of 4. Understood? So what is this? What is this range going to generate actually? This range of 5 is going to generate me the values 0, 1, 2, 3, and 4. Right? And this range is going to generate 0, 1, 2, and 3. Fine. Okay. So that's why I directly printed J, so that for every row 0, 1, 2, 3 is getting printed. Okay. So if I increase the value, let's say 7. Okay, the J loop range as 7. So this is going to run till 6, right? If I run the code, you will see this output. Fine. So what we have to understand here is the I loop is going to take care of the rows, and the J loop is going to take care of the columns. Okay, fine. So this is the output for this particular code. Now, so usually how the patterns are going to be is I'll be giving a number 4, so that a 4 cross 4 pattern will be printed. Okay, so n is equal to input, int of input, and I just change the values of range as n. Okay, now if I run the code, it'll be waiting for an input. Okay, if I give 5, you can see a 5 cross 5 pattern is getting printed, right? So if I give 10, you can see a 10 cross 10 pattern is getting printed. Okay, fine. So this is how the nested looping works. Okay, so I'll give you certain exercises now. So what if I want this kind of a pattern to be printed? For input 4, I want this kind of an input, this kind of a pattern to be printed. So can you tell me the logic? Yes. So if I give 4, this pattern will be printed, should be printed. If I give 5, 5 cross 5 pattern should be printed. Can anyone tell the logic for this? So obviously you have to take an input, n is equal to int of input, and then so how many rows are there? There are n rows, right? So based on the input, there are n rows. So I have to run the I loop for n times. Sorry, range. And then, so how many columns are there? 5 columns are there. For I in j in range of n. Now, if you clearly see, like this entire row, the same value is being printed. Okay, entire row, same value is being printed, right? But j value changes for every iteration. J value changes. Only thing that doesn't change for this entire row is the I value, right? So I already got an answer in the comment. Very good. So the I value doesn't change for this entire row. So can we make use of this I value to print? Yes. So the answer is print of I. That's it. So you have to give proper end statements. Okay, so what is the purpose of this print over here? After finishing the loop, I put an print statement, right? So the purpose of this print is nothing but just to give a new line. So entire print statement inside the J loop are ending with a space. So once this entire row is printed, I have to move to the next row, right? For that purpose, I'm using this empty print statement. So it will just give a new line. That's it. Okay. So let me run this code. Give 5. So can I see? Zeros, ones, twos, threes, and fours. Okay. Fine. Now, I hope all of you understood. Any doubts, anyone? So this is the basics. Okay. So we're going to increase the complexity of the patterns. So if you haven't understood, kindly let me know. I'll explain it again. Because we're going to increase the pattern. Yeah, I'm going to give more examples now. So this is understood, right? As of now. Okay, let me continue. So the next pattern is going to be, if I give 4, the output should be 0, 1, 2, 3, 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6. Okay, so I want this pattern to be printed. So if I give 5 as the input, 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 3, 4, 5, 7, 4, 5, 6, 7, 8. So make it fast. We are running out of time, only 15 more minutes. Got an answer. It says that I plus plus. See, one important thing to be noted is don't ever manipulate or modify the iterator variables. Okay, so once you initialize it, this particular value has to be used. You can use it, but you should not update it, not change it. So don't modify the values, these iterator values. Instead, you can use some temporary values and then you can change. But don't change these values. Because the iteration will not happen properly. That's the reason. Anyone? So if I give the answer, it will be too simple. That's why I'm waiting for someone to give the answer. Yes, very good. So we got an answer. J in range of I comma I plus n. That's it. Okay. For I in range of n. Okay. And for J in range of the starting value is going to be I and the end value is going to be I plus n. That's it. Print J comma n is equal to this. Very good. So I execute the code. I give 4 as input. So can you see 0, 1, 2, 3, 1, 2, 3, 4, 3, 4, 5, 6, 3, 4, 5, 2, 3, 4, 5, and 3, 4, 5, 6. So I give 10 as input. So this is the output. Understood? Okay. So you can change the range values, the starting value and the end value of the range. Okay. And or you can also use additional values, additional variables, temporary variables to create the pattern. All those things can be done. So don't ever change the iterative variables. Don't update the values I equal to I plus 1 or I equal to j like that. Don't do that. Okay. So there is one more way to there's one more logic as well. So this is the better logic. Okay, this is a very good logic. I will give you one more logic. Just put range of n and here I plus j. This will also work. Okay, this will also work. Fine, both the answers are correct. So no issues in this. Any doubts in this? Can I proceed with the next pattern? So the next pattern is, so let us go make some character patterns. Okay. So the input is 4. We want this kind of a pattern. It is 5. This is very simple, right? Yes. What is the code for this? Yes, anyone? This is the simplest of the simplest. Yes, very good. Inside the print, you're going to put a star. That's it. Yeah. So print star. And the end with a space. So here the end is nothing, right? So not ending the print with anything. So you can give an empty string as well. Okay. If you don't want a space, just give a end with empty brackets. I mean empty double quotes. So 5, got a 5 cross 5 star pattern. 10, you got a 10 cross 10 star pattern. Okay, fine. Now, next my pattern is going to be give a 4, first line a single star, a double star, 3 stars, 4 stars. So can you try the logic for this? Yes, correct. So here what we need to do is just change the range of the J loop. Okay. So the range of I doesn't work, I plus 1 works. Okay. So I was here given the answer. A small correction, very good, but good try. So instead of n, I have to give I plus 1. The reason is I is starting from 0, right? If we give range of 0, then the loop itself will not run. So I'm giving range of 1 initially. So first time if it runs, it is range of 1. So second iteration, okay, it will be range of 2, then range of 3, range of 4. Like that, it increments. So the pattern would be an increasing star pattern. Okay. 10. Understood. Yeah. So someone has asked about, is there no I plus plus in Python? No. So there is no pre-increment, post-increment, increment and decrement operations will not work in Python. Okay, it's not supported actually. And now I want just the inverse of this pattern. So 4 means first 4 stars, then 3 stars, 2 stars, and 1 star. So what is the logic for this? Yes, very good. So it should be n minus I. Okay, it should be the second loop should end with n minus I. So every time I is increasing, right? So I should reduce the number of times the J loop is running every time. So n minus I. So I can make use of the increasing property of I. Okay. So let me run the code. 4. So you got the inverted triangle pattern. Okay. So 10 inverted triangle pattern. Understood? Okay. Now, so I want this triangle pattern to be filled with numbers. Okay. The next pattern is going to be 0, 0, 1, 0, 1, 2, 0, 1, 2, 3. Okay. So what is the program for this? Yes. So it is similar to this, just print similar to the increasing star pattern. Okay, so triangle pattern. So instead of star, print J. That's it. Okay. That's it. Now, my next question is, for we want 0, 0, 0, 0, 1, 1, 0, 0, 1, 1, 2, 2, 0, 0, 1, 1, 2, 2, 3, 3. So what is the program for this? So if anyone is not able to understand, kindly stop me. You can ask the doubts. So you're all here to learn, right? So don't hesitate to ask the question. Yes, very good. So you have to print J twice. That's it. Okay, this similar to the previous pattern. Only thing is the printing is happening twice. Okay, so I will use make use of the same code. So instead of printing it in two print statements, you can also write like this: J comma J, and separate it using again empty quotes. Okay, separation is also empty, empty string. End is also empty string. Now if I execute, 000011, and it goes on like that. Understood? Fine. Okay. Now we are going to get little more tougher. Okay, so this is a combination of two patterns. Okay, so I'm not revealing much. I'll give the pattern. You try to find out the logic. So I want you to write a logic for this particular pattern. I would like to take 10 more minutes of your time so that I could finish off the pattern. Okay. So tomorrow we will start with the sequence types. So these are all logic building exercises. Okay. So like I said you, it is the control statement. So your brain is what is controlling, right? So to make your brain active, you should practice with a lot of control statements. Okay. So this is the decision making statements for the programming language. Okay, so that's why we're having a lot of exercises in this looping. Yeah. So anyone has the answer for this, or shall I give the answer? Okay, so it is quite difficult for beginners. Okay, so I'll tell you. So this is an combination of two patterns. Okay, it's the combination of two patterns. The one pattern is the zero pattern. I got an answer, but see, actually, you cannot use. So you should not use three loops. Okay, that is not correct. Okay, anyway, I'll give you the answer. So this is your first pattern. Okay, this is your first pattern, and the second pattern is, you just visualize it properly. If I remove all the zeros, okay, if I remove all the zeros, what will I be left out with? This pattern, right? One pattern, one. So if I combine these two patterns, I'll get this pattern. So how to combine is the question, right? Okay. So first, let us write the logic for this pattern alone. Okay. The zero pattern alone, we're going to write the logic. So that is quite simple. We already have a lot of See here only zeros are being printed, right? Okay, just zero is enough. Don't print J or I, nothing. So it is a normal character, zero character. That's it. So instead here you can use star, you can use hash instead of one. So all those things can be done. So if I run this code, I will get, okay. So the triangle pattern for zero alone. Now, after the execution of every row, I need this particular pattern, right? Okay. So for printing one, what I should do is the same pattern, right? Only changes the one. Okay. So after the execution of the zero pattern, I need one pattern for every line. Okay. So for every line. So in the first line, the first row, I have first zero pattern printed, then the one pattern being printed. The second line, I have zero pattern printed, then the one pattern getting printed. So that is what is happening here. So this particular loop, J loop, can you see I am using J loop for both these patterns? This is possible if there is no nesting. Okay, so this loop and this loop are not nested. Only this I loop and this J loops are nested. This J loop and this J loop are not nested. Okay, fine. So here, yeah. So after this J loop, after this zero pattern got printed, this one pattern will get printed. So this is the logic. Okay, let me run it and show it to you. That's it. Okay, I'll give one more example. So 10. So this is the combination of multiple patterns. Okay, if we have if we have two also here, so what will happen? You have to include one more loop like this. I'll show that as well. So instead of one, we need to put a two. Okay, so you run. So can you see zero pattern, one pattern, and two pattern combined together? So this is how the pattern works. Fine. Now the next thing, just give me the logic for this. Okay, 4 0 1 1 1 1. Okay, 0 0 1 1 1 0 0 0 1 1 0 0 0 0 1. So just try the logic for this. Okay, this is also a combination of multiple patterns. Okay, so similar to previous, but small change in the looping will create this kind of a pattern. Small change in the range values will create this pattern. Is anyone? Yes. Very good. I got the answer. The second loop has to be changed with instead of instead of I plus 1, it is n minus I. So can you see, like, this is the inverted triangle pattern, right? So this 4 ones, we already seen the inverted triangle pattern. You could recall it. Yeah, so this inverted triangle pattern. So how does this work? By giving n minus I, right? So the same thing works here as well. 5, you got this pattern, right? So the 0 is the normal triangle and this 1 is the inverted triangle. Got it? So this is how we have to combine multiple patterns. Okay. And one more last pattern. So with this, we can wind up today's session. For 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1. So this is actually simple. Just try to make it fast. Yes. Yes. Anyone? See, actually, this is simple. See, you have to print this pattern first and this pattern second. Okay. So you have to print. You have to first form this pattern. Followed by the one pattern. That's it. Okay. First 0. This will print the 0 pattern, and this is going to print the 1 pattern. That's it. Very simple. Okay. These are two different patterns. Only thing is it is in a single, like, continuous manner, right? Okay. Okay. So 0 pattern followed by the 1 pattern. Understood? Okay. Yeah. So I'll give you a few exercises which you can practice and see. So, just by normal patterns, you will not be much excited. So I thought of giving you exercises based on the national flags. Okay. So just take. So this is the national flag of Germany, right? So it is the combination of 3 colors. Okay, black, red, and yellow. So here, black. So just have some symbols, okay? So very simple. Like, you may not give a color. Instead, this black can be a star. Okay, and then red. I'll give you an example as well. Okay, red can be a cap symbol. Okay, and then yellow. Can be a hash. Okay, so if I give 6 as the number, okay, I want a 6 cross 6 pattern. So how does the flag look like? So, star, 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 star. Okay, and then cap, cap, cap. And then hash. So if I give a space in between, it looks like a rectangle, right? So this is a 6 cross 6. Assume that, see, there are different colors, right? So assume that it is a multiple of 6, sorry, multiple of 3. Okay, so that the pattern looks even. Okay, so else it looks odd. So multiple of 3. So for 9, it is going to be then. Okay, so for any multiple of 9, 3 I give, I'm going to get a similar pattern like this. Okay, so take something national flags like this. Okay, so I would like you to try out these flags. Okay, so German flag, Italy flag, and Denmark flag. Denmark. Just try out, it'll be interesting. Okay, fine. So thank you so much. So we can call for the day. So
Right, guys.
yeah, yes, sir.
JK?
Yes, sir, yes, sir. So the class is
Okay.
done, sir. For today.
Right. So I hope all of you had a good time for the last 2.5 hours. And we will go deep into the practice sessions tomorrow. So, JK, any assignments for them today?
Yes, sir. I've given them some assignments to do.
Brilliant. So, please, guys, the whole objective is to go and practice whatever you have learned. So do not delay. Tomorrow, whenever you have time, go and play around and practice some of the things. And we'll see you again tomorrow, yeah? Same time.